So it's 2:30. So let's start. So hello everyone. Yeah, thanks and for joining, and we're back here for another interesting session. And thanks again for taking time to join. I can see quite a few of you here already. So today we're here to talk about the uh, process and automation industry as a whole, right? Like, and then how safety plays a critical role. And I hope the takeaway from this session is to have a comprehensive overview on safety standards in process automation itself, right? So today I'm Nitin, and I'll be your host and moderator for today. And I hope to sort of garner all the questions that you might have for our expert here. So I have with me Jagjeet, our industrial SME as well as embedded expert. I'm sure you would have heard about quite a few topics from him in our previous sessions around APL, Ethernet, APL, hard, functional safety, and a lot more, right? So I think who better to sort of talk about uh, the entire safety standards in one go, right? To talk about the full umbrella itself. So, yeah, a couple of quick logistics. So, we'll have the session for about 30 minutes and we'll switch over to a Q&A. Whoever has any questions, so just drop it in the comment box and I'll relay those things for Jagjeet. Right. So, okay, so let's get started. So, to start off, firstly, I think it's important to understand the need for safety standards in process automation in particular. So Jagjit, as like process automation itself, right? It's a big bracket of sub-industry segments like oil and gas, chemicals, pharma, packaging, and all these other metals and multiple industries like that. So from a safety standpoint, uh, is that a common standard that is applicable for the overarching process industry, or are there any specific like nuances of those standards or subcategories that are applicable to each of those individual industries?
Yeah, thank you, Nitin, for this opportunity. Yeah, so definitely in safety standard and process automations, I hope I'm audible, right, Nitin?
Yeah, yeah, very clear.
Yeah. So it's definitely there are different way of addressing this. Say example in process automation means that we are talking about I would say like a water bottle industry. Okay, take an example of process automation, and similarly we are talking about oil and gas industry. So, so if you see the safety level aspects, if you consider for both this industry, I think it will not match because when you go for an oil and gas industry, definitely we need to take care a lot of other aspects because it's a more hazardous area, and there are a lot of inflammable particles are present or vapors from the gasoline or any other inflammable materials or hazardous chemicals. So these things are present. But when you're talking about a bottling industry, which is the kind of any beverage bottling industry, the safety is coming into a different criteria. So generally, we follow various safety standards. When you're talking about anything on the hazardous and oil and gas other area, we follow intrinsic safety. And functional safety is basically on industrial products. It could be a mission critical electronics or mission critical products related systems. And apart from all these things, there are many other safety aspects, but we are restricted, or I would say like that. In this conversation, we are talking only this intrinsic safety and functional safety aspects. Apart from that, you can see that most of the devices which we are using, either consumer electronics or any other industrial products, you can see the CE marking. So C is basically European conformity. So C also include various electrical and as well as environmental, and plus safety standard is also included in C.
Okay, thanks, Jagjit. So I think you covered those three broad aspects like you've shown on screen, right? Like in terms of intrinsic safety, functional safety, and C, and broadly all those standards fall under these big categories, and that might be a little more detailed with respect to those industries that are applicable for it. So let's probably start with getting into a little more detail on the functional safety aspect of it. So if you can give us some more information on how functional safety uh, came about, and like in terms of what goes into it and what is some of the the key sort of attributes of functional safety itself, then that would be good.
Yeah. So functional safety, again, functional safety defined so various industries, as you can see in this slide. Based on the industry, it has a various standards. And so we are talking about the functional safety, which is specifically into the industrial side, basically IEC 615 double one. So it has a various safety integrated level. So basically we can say SIL 1, SIL 2, and SIL 3 and SIL 4. So each level it's differentiating in terms of their safety critical aspects. So SIL 1 is basically represent the integrity required to avoid relatively minor incidents. So that's not a major incident or something that's likely to be like certain degree of fault tolerant by design using guidelines, and that follows some good practice. So it may be how we can ensure that the design will not create any failure, and how we can ensure that with following some certain practices to have a safe design, so that will not create any safety threat. SIL 2, maybe it is a little higher level compared to SIL 1. That is to avoid a more serious and but limited incidents. So that is also mostly focusing into the design aspects, how we can ensure that with any fault or any other design issue, it should not create any major injury, like risk to a death or any other major critical issue for the business or the assets. And SIL 3 is it is little more, which we are talking about the serious issues or the serious failure. So in the SIL 3 side, we will talk about more in terms of redundancy aspects. Like take an example of a system which is running with a two drive, okay, which is controlling a motor. And in that cases, the drive failure should not cause any issue for that. So for that motor, so that we can have a redundant system to drive that motor. So that is one use cases. SIL 4 is more. I would say it's avoid any disastrous accident. I would say any. It should not create any catastrophic situation in as per the SIL 4. So basically, if you talk about any atomic plant, or I would say like any refinery, where SIL 4 is very critical. So most of the cases, what happen, SIL 2 and SIL 3 in the instrumentation level, people are taking caring. But when we go for the next level of as I said, the nuclear plant or anything related to any refinery, those things matters.
Okay, so I think to just summarize, you mentioned about the IC 61511, which is a little more applicable only to the this industry, and there are similar such things that are applicable for their respective industries, and how the safety integrity level, depending on the use case and the application, is sort of split into these four levels, like you said, right? So probably now, I think we can, yeah, go on if you want to add some points.
No. Anyway, this point is covered, but it's actually derived from a parent safety standard IEC 61508. That's a functional safety standard. But see, end of the day, the functional safety is describing something like that. Avoid any injuries. End of the day, what happened? It should not create any safety threat in terms of I would say like the people, or it should not create any severe damage for the investment infrastructure or the plant. So definitely, in the automotive, we are talking about ISO 26262, but the parent safety standard is IEC 61508.
Got it. Got it. Cool. So yeah, I think we have a good overview on functional safety. Now let's probably jump into the second aspect that you previously mentioned, right? The intrinsic safety portion. Can you again give us a brief on the intrinsic safety side, and is there any sort of similar classification like what you mentioned here, the functional safety? And yeah, that would be great.
Yeah, intrinsic safety, definitely, as you can see in this slide. So it's intrinsic safety, which we are talking about to, uh, so mostly applicable in the explosion area, or I would say like where hazardous situations, right? It could be a, uh, hazardous gases, which is highly inflammable, or some kind of a chemical, or I would say like any other vapor presence in that, or any other air, so dust or debris, such kind of things. So there are different level of protection in intrinsic safety standard. Also, that is also based on IEC 60079 standard. So IA means at highest protection. It's the most hazardous area, zone zero, take an example of a gasoline station where when you are filling the petrol or any other oil into another container, definitely there are a lot of flames are present. So there are 100% chances of getting the flame, okay, that can ignite any other electronics or systems, and or that's level. So when you're designing the system, the system should not create any kind of electrical energy to the atmosphere that should not trigger any ignition. That's what all about the intrinsic safety level. So that is again classified into IA, IB, and as well as IC. So IA is mostly 100% inflammable contents are present, and IB is at most likely. IC is very occasionally the inflammable contents are present. So, and based on that, there are design criteria also, that zone one, zone zero, zone one, and zone two. So IA means that the highest protection is for the most hazardous area, basically two countable fault. So say example, if you're talking about a fuse which is actually carrying a certain current, and once the current is exceeded, that the fuse will disconnect the circuit so that it will avoid such kind of a fault. So in that cases we might be having a double fault protection. So if I am considering about one set of electrical circuit, I'll be having a two set of electrical circuit which is having a different rating. And similar way, the fall protection we always consider 1.5 times of the rating. Say example, if we are considering about a 1 voltage is something is our the cutoff voltage, definitely we'll have a 1.5 voltage consider for the design side. That's when you're talking about IA specifically. IB
Got it.
means that that is also one countable fault. We will not go for multiple protections, but definitely the safety factor will consider 1.5 in terms of rating. But when it is come for IC zone 2, where most likely take an example of a petrol station where you are filling the petrol, and definitely there is a place where their office is situated. That's something which we can treat like a IC where zone 2, where likely most very unlikely inflammable components are present. So in that cases, we will not go for any 1.5 safety factor, but we will consider unity safety factor with maybe a probably with a using a fuse or any other electrical circuit. We will prevent creating next level of ignition or any other issues.
Got it. Got it. So you mentioned about a few things there, right? Like in terms of the categories and all of those things. Like maybe it will probably even help the audience if we understand how that individual sort of categorization, as well as how that in turn comes about when a system or a process is intrinsic safety certified. How does that sort of translate into the actual marking itself, and what goes into that?
So Nathan, that's a very big topic to cover in this 30 minute side, definitely. And but what happened, I can go through
Sure,
this particular slide here, and we can have a very detailed session uh, about this. So
sure.
explosion proof, definitely the marking is start with the EX. So as I indicated, it has a subgroup. So it's basically one or two we can. So for use in underground mines is one, and basically in other places it is two. So generally we can see that EX2. Generally any marking is start with the people are using in the outdoor application is coming with an EX2 marking in the beginning. Then again category 1, 2, 3. This is already we have discussed about that. There is a category 1 means that it's include the area where explosive atmosphere is present continuously. Say example, if you are in a the gas station where you are filling the gas, so there is 100% chance that the inflammable components are present. So that's a category 1. And category 2 is something like that the area explosive atmosphere is likely to occur in a normal operation. So in a normal operation, it's may not be a chance, like maybe some area where you are using a safety valve and something which you are transferring the gas to one station to another station, or any inflammable component in that matter. But in that cases, sometimes because of the loose contact or some other reason, if the gas is leak, or that can cause a explosion or something like that, that is coming into the category 2. Category 3, something like that, it's a very, very rare chance to occur such kind of a situation. But there is a chance. It may be because of any other accident or something like that. So that's the way it will classify the category. Again, that is categorized into gas and dust. So definitely G is indicating for the gas and D is for dust. Dust is also something on the debris which is inflammable. And type of protection, again, it's a flame proof. IA means are intrinsically safe, and the E means increased safety. So, again, I will not go in detail, but
Sure.
intrinsically safe means that it's a design. By design, we will ensure that that particular electronics or the electrical component will not create or will not discharge any sort of energy to the field. So, that energy should not create any ignition. That's what it's called intrinsically safe. Flame proof means that generally what happen, we will have an enclosure, even though the electronics or electrical system can discharge such kind of electricity or any kind of a energy which is enough to ignite something. So that something is arrested in a flame proof enclosure. So
Correct.
that category will go. And again, the gas group, and again, there are sub gas group, and there are temperature classification, various temperature level based on the operation range that can vary from 85 to 450 degree. Yeah.
Correct. So I would assume, like, after that entire process of going with this is how it would look, right? So, and
Exactly. Yeah. So maybe if you open any intrinsically safe design in the process automation, or it could be any gas transmitter or any IO module or any barrier, you can see similar kind of marking. So maybe audience can refer this slide later, where you can go through and exactly you can see that where exactly this marking, how exactly this is classified. By reading this marking, you can make out that even what kind of design it is, where exactly it is designed. Even you can make out that in terms of accredited laboratory who put this marking.
mhm. Got it. Great. So now I think we understand at a very high level nitty-gritty of what goes into it and all that, right? But now I think, considering a large portion of our audience is from the engineering side, and a lot of these industrial OEMs are building products along these standards, it will be good if you can sort of give us some details and on understanding the design process and the approach that you typically take when you're sort of designing products to meet these standards, right? So I think that would help a lot of us.
So this is a typical design process. Definitely, there is something which we can talk in detail about that. So the product specification is something which uh, we always start with that. So when you talk about the intrinsic safe design, this is typical design process for any product. So definitely we should have a control plan. So control plan means that all over the mechanical, electrical, or the system design, whatever we are talking, it should have a controlled copy in terms of versioning and everything. So the safety side, definitely on the mechanical side, we need to be unsure about the, what kind of chassis or enclosure we are using, because we discussed the few slide back about the chassis, right? It's if it is an explosion proof, what kind of chassis we are going to use it, and what kind of shielding you are going to use it, because that should not create any electrical discharge to the field. And similar way, kind of a material selection, whether it is an SS or MS, and what temperature which this is going to withstand in case of any flame or something like that. And similar way for the gasket and cover, because this any burning or something is happening inside the enclosure, it should not discharge any kind of an hazardous gas or any flame outside that enclosure. Obviously on the grounding side, because most of the systems are operated in electrical systems, so we should have a proper grounding and shielding, and related to the chassis components also we need to be very careful. Coming to the electronics, which is mostly on the schematics and PCB side, what kind of PCB? Because when we're talking about the intrinsic safe aspects, definitely there are multiple way of doing that, and each zone level we need to classify it. And when you're designing the PCB, number of layers and the stack up and separation of ground. So these things are already defined in the standards. So based on that, we need to address all these aspects in our electrical designs. And finally, when it is come to the system design, see, we need see end of the day what happened, everything has to be combined electrical, mechanical system, and this will go part of a system or a plant. So in that cases, we need to have a complete understanding about the power conversion and distribution and signal distribution. So under that, there are various things, topology, right? How exactly you are going to take the electrical system towards your end product. It could be a sensor or actuator. What kind of connector we are going to use it. Certain cases, what happen, you might be using a power supply. what kind of power supply you are going to use it, whether these power supplies and systems are certified for this kind of system or environment, has to look into that. And signal distribution, of course, we may deal with various signals. It could be a differential signals, cable harnessing, and similar way antennas. So if you are using an intrinsic safe environment, there are specially designed antenna which is recommended to use in that field. That's something which we have to select it. So we are not limited only with certain instruments. Definitely all our associated components in terms of mechanical, electrical system designs are contributing to this design process.
Got it. Got it. Understood. So those are, like, I would say, the high level sort of overview on how individual sort of functional aspect of how the electrical, mechanical, and all of that will have to play a role with the individual things coming together, right? In terms of the actual process itself, like if you can give us some more details, like from let's say the I think what the slide you show is from an analysis to the certification, the full life cycle of how that sort of goes about, and and what really goes into some of those analysis, that will be helpful as well.
Yeah, so let's talk about the functional safety process. Again, this is a very limited content, but still, this is the way generally we will design. So, this is a scenario we are talking about a new design, like basically when you are designing or when you are in a stage of a new product development, right? So first you need to understand what hazard analysis, right? So it's like a safety measure and recognizing that potential hazard in that plant, which I discussed when you're talking about a water plant or where you are doing a water bottle uh, bottling industry and talking about an oil and gas industry. Definitely it is very easy for you to differentiate what exactly the hazardous level, right? So definitely when it's oil and gas, more inflammable gases are present. But when you're talking about a system which is having a mineral water plant, where you have to take care more into the contamination of water. So that level we should understand the process and we should have an understanding about the hazardous level. Then based on that, we should have a process risk analysis. So obviously when you're talking about this kind of system, there are various processes involved. So, what kind of hazardous severity level and how frequently this is occurring, and what is the possibility to avoid such kind of hazardous and other elements are determining the safety integrated level required for each safety integrated system. So those things we need to have an analysis, and that something is critical input to determine what level of safety integrated level is required. So by looking into that, we have to do an average failure analysis. And once we do the failure analysis, we will design what cell level is required. So we discuss about the cell 1, 2, 3, 4 level. And based on that,
Yeah.
we will have a category and we will categorize that system. Then we will go for, after designing and everything, we will go for the verification of the cell. So that's again, it has a various failure conditions. So when we're talking about the process automation standard under IEC 61508, 61511 has a lot of standard, and based on that, what happened, we will verify all the safety integrated level. Say example, if you're talking about a redundant system, we will verify all the design aspects, whether this particular design is meeting all the safety standards, so that it will do a fail safe instead of creating a catastrophic situations. Once that is done, that will go for the testing and validation. That's based on the system level. We'll work with the various agency and understand that how the test is conducted, all the system level, everything. And once that is done, it will go for the certifications. And this is not limited only for instruments, for your information, Nitin. And definitely safety is not we are talking about only for the device, because safety as a process, as an organization, as an R&D organization, they have to follow some safety process. And after commissioning the product also, definitely the safety will continue even till decommissioning the product. The safety life cycle has to follow.
Understood. Okay. So probably like so now that you've gone through the entire design process and sort of explained to us what goes into each of these sub processes, right? Like now, I think it will be good if you can give us some more inputs on. There might be a specific process that is related to the certification side of things that is related to this, right? So some more details on how the certification process itself works, and what goes into that, and what are the typical sort of activities that happen through this process.
So I'll take an example which you discussed, like the intrinsic safety certification process here. So this is one example or one use cases. So there are two processes, right? One is in the design, another one is in the production stage. Okay. So as we discussed in the previous stage, definitely we are going to have kind of an hazardous analysis where actually the category, everything once it is done. So this is a typical process we do that. So something is first what we will do, we have an internal control productions, and once that is done, the technical file we are going to create it. Once the technical file and everything is created, we are going for the conformity. So that's based on the internal production, and with an external agency, we are going to do the product testings. And that's something again will go for the conformity with the certification authority. So once that certification authority, everything is done, we will go for a unit verification, and that is a closed loop thing. And finally, what happen? You will get the ECX marking. So this is divided into design and production. So basically, what happened in the design stage also, we need to take care all this kind of examination as per the standard. So this annexure specification is as per the standard of intrinsic safety aspects. And definitely, when it is go for the production, also we need to see all the aspects in terms of quality assurance for all zone. Like we are talking about zone 0 to zone 2 here. So zone 0, zone 1, and zone 2, we can follow this kind of process.
Got it. Great. So probably like so we touched on intrinsic safety and functional safety, and what goes into all of those processes when you're designing and sort of certifying products for those standards, right? So I think initially you were touched very at a high level on CE and some of the low voltage derivatives or LVD, as you had very at a high level mentioned. Can you probably shed some light on that before we sort of conclude that full thing we set out at the beginning?
Yeah, so that just want to touch base on that, because what happened, safety, we maybe the audience may feel that the safety is only we are talking about the functional safety or intrinsic safety, but safety is not limited only with that those standards. Definitely, there are multiple standards and other thing into the safety when it is come to the process automation side. And I really want to share that in the CE side. So CE is something which you can see the European conformity, which is I think almost to all products you can see the CE marking.
Hmm.
So C is consist of two elements. Maybe in a very high level, I'm discussing here. So that's something which we can talk about uh, the EMI EMC electrical aspects of that, which is based on the product. So C could be applicable from a toy car to an aircraft system, right? So there are various components are involved and various standard. I'm not going in detail. So one is the electrical aspects, and second thing is the environmental aspects, right? So electrical aspects means that basically it is talking about the various noise level, because the device what we have designed, it should not disturb the other system, and similar way the other system whatever it is creating the noise should not have an impact on the other system. I mean the device what we have designed. So that is on the noise level aspects. And similar way, we should not use any hazardous component inside the system, so that tomorrow when it is recycling, it should not create any pollution to the earth or environment. That's the idea. And the third thing, it's there is one directive in the C is called the low voltage directive. So that is based on the standard EN 60335-1. That's the primary purpose is something like that to assure all products are defined in the electrical equipments and placed in the EU market in the safe, and use does not have any health issue or any other electrical related issue to anyone nearby. So that the standard defined basically for alternating current, it's something 52,000 voltage, and similarly for the direct current 75 to 1,500 voltage. So so that has a lot of other aspects. Definitely in our next session we can go in detail about the C specifically, and all the under the C there are multiple directives. We can go in detail about that.
Sure, sure, no worries. So I think, yeah, we try to pack as much as possible, and you also try to cover as much as possible this 30 minutes. Uh, so yeah, I'll just see if I can pick up some questions from the audience. So Ahmed says, "Can you share this?" Yeah, of course, we'll send it across to you. Uh, is functional safety only for devices and systems, but is it also applicable for a software tool? Yeah, that's an interesting one.
Yeah, very interesting thing, right? So definitely we are not talking about hardware or something like that. Say example, if you are talking about a system where your pressure limit is 100 PS and you are reading a pressure and you are writing a code for 100, some 100 PS or something like that, but actually the safety limit is something around 50. So any coding error can also create a such kind of issue. So definitely safety standard is not limited only with electrical system. There is a strict coding guidelines as per the functional safety standard which we have to follow it, and that will ensure that any coding guidelines or any software issue should not have any impact, because most of the systems are now embedded system which is having the both hardware and software firmware components. So functional safety is not limited only for software or hardware or the system level. Yes, software is also applicable.
Got it, got it. Another quick question which we have is, are there any safety standards specifically to any protocols as such?
Yeah, of course, because when you're talking about the safety standards, again, the system, when you're talking about two system, it is communicating over communication protocol. So your two systems are meeting all the safety standard. That is not ensuring the complete safety until unless your communication protocol are safe. So an example, ProfiSafe is one example which is actually defined the safety standard in Profinet. So that's the ProfiSafe version. And similar way we are talking about in Ethernet IP, SIP safety is more about the safety standard, the communication protocols. These are some of the industrial protocol standards which is having the safety standard is already defined.
Okay, great. So maybe one final question. I have one question on behalf of the audience, Jagdeep. So where, again, let's say from an OEM perspective, we're building these industrial instruments and products, right? So uh, let's say they decide to embark on or introduce products with these specific safety standard requirements that their customers are asking for, and if they want, when they want to, when they decide to do so, what is the typical sort of additional timeline to sort of accommodate these safety aspects into the design, and sort of what is the implications on the safety certification process itself, and typically how long does it take? I know it's a long question and it's very vague, but again, some insights on that would help a lot of our engineering audience.
Yeah, yeah. I will not say it's a vague question. Definitely, I can answer it with an example. It's a case to case. It will vary, Nitin. So I'll take an example of a gas transmitter. So where you are having a gas transmitter which is actually detecting a potential gas leakage in a process automation plant, and so take that as an example. So we already know the category of the safety integrated level. Consider that is a SIL 3 level safety is required, and intrinsic safety is also very critical on that. So considering these two safety standards, so typically what happens, the design stage, it will take 4 to 5 months. So that design, including the schematics and all the mathematics related to the electrical and the PCB related things. And so that we can cover 4 to 5 months time. So then again, a 1 or 2 months time for the verification and other things. So considering another 3 months for the lab verifications and doing a pre-production and functional testing. So typically it will take 9 to 10 months for such kind of a product design. And after the 10th month, definitely there are a lot of functional field level testing is required, considering another 3 months for the field level testing and getting all the approval and all the pre-production beta version once it is tested, validated from the field, and that can go for production. So totally, I would say like within 18 months of product
Okay,
development life cycle, including the pre-production, we can launch the product. I'm just taking an example of discrete
sure,
is
sure.
one gas transmitter use cases. Definitely that timeline will vary based on many other product and as well as the safety integrated level.
Great, great. Yeah. Yeah, I think we have addressed all these questions that were raised, and yeah, no, we can go on and get into more details. So, if you guys would like to listen to Jagjit in terms of some more specifics on this topic related to safety aspects, functional safety, intrinsic safety, and he basically leads a team of certified engineers in this space, right? And they do a lot of work in the industrial automation space for process automation specifically with a lot of the OEMs. So if you'd like to sort of probably get into some more details or understand what these guys can help you with, or probably even pick their brains on specific questions, we can have another session specifically in a little more detail. But I think for now, I think in terms of what we wanted to understand as a comprehensive overview, I believe we did. And thanks again, Jagjit, for coming on board and giving your inputs and insights into this topic. So, yep. And finally, again, thanks everyone for joining. And if you have any questions, again, the comment sections is open, so you can always put it there, and we'll get back to you with any responses from our side. And to just wind up, again, stay tuned. We have more such sessions, particularly in the process automation thing over the next few weeks that we want to cover. So, guys in the process automation industry, stay tuned. We'd love to listen to you, and I hope we can add some value to your time. Great. So, thanks, Jagjeet. Thanks, audience, and
Thank you.
goodbye.
Thank you.
We'll see you soon. Thank you.
Thank you. Thank you so much. Bye.